An automatic transfer switch, ATS, is an electrical device used to automatically transfer power supply from one source to another in the event of a power outage or voltage abnormality. It is commonly used in backup power systems to ensure uninterrupted power supply to critical loads. ATS works by monitoring the availability and quality of power from the primary source, usually the utility power grid, and a secondary source, typically a backup generator. When the primary source fails or falls below acceptable voltage levels, the ATS quickly switches the load connection from the primary source to the secondary source. Here's a step-by-step breakdown of how an ATS typically functions. Monitoring. The ATS continuously monitors the voltage, frequency, and other parameters of the primary source and the secondary source. Power source selection. When the ATS detects a power loss or abnormality in the primary source, it initiates the transfer process. It verifies the availability and stability of the secondary source before making the switch. Source breaker open. The ATS opens the circuit breaker or disconnects the load connection from the primary source, ensuring a safe disconnection. Delay timer. Some ATS models include a delay timer to allow a brief pause, typically a few seconds, before initiating the transfer. This delay allows the secondary source to stabilize and reach the desired voltage and frequency levels. Source breaker close. Once the delay timer elapses, the ATS closes the circuit breaker or reconnects the load to the secondary source. Monitoring the primary source. Even after the transfer, the ATS continuously monitors the primary source. Once the primary source is restored to normal conditions, the ATS waits for a predefined duration to ensure its stability before initiating a transfer back to the primary source. Source return. Once the primary source is stable, the ATS reopens the circuit breaker or disconnects the load from the secondary source and reconnects it to the primary source. This automatic switching process ensures that critical loads receive uninterrupted power supply, reducing downtime and maintaining continuity of operations. The main functions and purposes of an automatic transfer switch, ATS, are as follows. Power source selection. The primary function of an ATS is to automatically select and switch between different power sources, such as the utility grid and a backup generator. It monitors the availability and quality of power from these sources and transfers the load connection to the available source when needed. Uninterrupted power supply. The ATS ensures uninterrupted power supply to critical loads by swiftly transferring the load from the primary source to the backup source in the event of a power outage, voltage sag, or other abnormal conditions. This helps maintain continuity of operations and prevents disruptions. Seamless transfer. The ATS performs the transfer between power sources seamlessly, with minimal or no interruption to the connected equipment or loads. It typically achieves this by using mechanisms such as synchronization and delay timers to ensure a smooth transition. Load balancing. Some advanced ATS models support load balancing between multiple power sources. They can intelligently distribute the load across available sources, optimizing the power usage and reducing the strain on any single source. Monitoring and protection. ATS systems continuously monitor the voltage, frequency, and other parameters of the power sources. They can detect abnormalities, such as voltage fluctuations, frequency variations, or phase imbalances. If any issues are detected, the ATS can initiate the transfer process to protect the connected equipment from potential damage. Safety and code compliance. ATS systems are designed to meet safety standards and electrical codes. They incorporate features like mechanical interlocks, ground fault protection, and surge suppression to ensure safe and reliable operation. Compliance with relevant codes and regulations is crucial to ensure the proper installation and use of ATS systems. Manual override. While ATS systems are primarily automated, they often include manual override capabilities. This allows operators or maintenance personnel to manually initiate or control the transfer process when needed, providing flexibility and control in certain situations. When selecting an automatic transfer switch, ATS, several key features and specifications should be considered. These factors help ensure that the ATS meets your specific requirements and is compatible with your power system. Here are some important features and specifications to consider. Current rating. The ATS should have a current rating that matches or exceeds the maximum load capacity of your electrical system. It is crucial to consider both the normal operating current and any potential surge currents during startup or motor loads. Voltage rating. Verify that the ATS is designed to operate at the voltage level of your power system. It should be compatible with the nominal voltage of your primary source and secondary source, backup generator or alternative power source. Number of poles. Determine the number of poles required for your application. ATS systems are available in various configurations, such as single pole, double pole, or triple pole. The number of poles depends on the specific requirements of your electrical system and the load you intend to connect. Transfer time. Consider the transfer time of the ATS. It is typically expressed in milliseconds and represents the time it takes for the ATS to switch from the primary source to the secondary source. Look for an ATS with a fast transfer time to ensure minimal interruption to your critical loads. Transition type. ATS systems offer different transition types: open transition and closed transition. Open transition refers to a momentary interruption in power during the transfer, while closed transition provides a seamless transfer without any power interruption. Choose the transition type that best suits your application requirements. Control and monitoring. Evaluate the control and monitoring features of the ATS. It should have clear status indication lights or a display panel for monitoring the power sources, load status, alarms, and system diagnostics. Some ATS models may also offer remote monitoring and control capabilities. Safety features. Check for safety features such as overcurrent protection, short circuit protection, ground fault protection, and surge protection. These features help protect your electrical system and connected loads from potential damage due to electrical faults or power abnormalities. Enclosure type. Consider the enclosure type of the ATS. It should be suitable for the installation environment, whether it's indoors or outdoors. The enclosure should provide proper protection against environmental factors such as dust, moisture, and temperature variations. Compliance and certifications. Ensure that the ATS meets relevant industry standards and certifications. Look for certifications such as OL, Underwriters Laboratories, or CSA, Canadian Standards Association, to ensure the product's safety and reliability. Service and support. Consider the availability of service and support from the manufacturer or supplier. Check for warranty options, technical support, and the availability of spare parts or accessories.